Hello everyone, welcome to JLD Academy, and today we are going to learn about the tachometry. In the tachometry, we are going to derive the equation for the horizontal distance and the reduced levels when the stop is vertical. Okay, let's start. So this is the setup. Here the vertical stop is vertical, and this is the theta angle of elevation. This is the horizontal distance, and we have to find out the RL of P. So for deriving the equation, first of all we have taken a triangle as, this is our triangle. Suppose this is C, this is B, this is A, B, C. I have taken out a triangle like A, B, C. In that, the D is the horizontal distance, L is the line of sight, and V is the vertical distance. We have to find out the D and the L. For L, we have a formula, like we have taken in our previous classes. We have derived that formula, line of sight. This is the horizontal distance D, and this is the vertical distance V. To find out the horizontal distance V, from the basic consideration of trigonometry, the cos theta and the sin theta is cos theta is adjacent by hypotenuse and sin theta is opposite by hypotenuse. So I have written that cos theta is equals to D by L, sin theta is equals to V by L. So that D is equals to, here from that this equation, D is equals to L cos theta. And what is the L? L is the line of sight. L is equals to K into S plus C. Okay, where the K is, we have derived this equation K into normal stop intercept plus C. We have derived that for the when the stop is normal to the line of sight. Okay, but here the stop is not normal to the line of sight. For that, when we have taken a normal stop, here is the triangle, S is a stop intercept, and we have to find out the X. We don't need normal stop, we don't need only a stop intercept, we need normal stop intercept. So that X is our normal stop intercept. Here cos alpha is equals to adjacent X by hypotenuse. Okay, so we got that X is equals to S cos theta. Here is X is equals to S cos theta. I have substituted in this equation, that is L is equals to K into S cos theta plus C. D is equals to L cos theta is first equation. L is equals to K into S cos theta plus C is our second equation. We are substituting L in the first equation. We got the equation of horizontal distance as D is equals to Ks cos square theta plus C cos theta. Whenever we are using an analytical lens, we have that K is equals to 100 and C is equals to 0. In that, here the C is 0. If we substitute in this whole component is vanishes. So only the D is equals to Ks cos square theta, where theta is the angle of elevation, K is F by A, that is analytical constant. This will be given in the question as K. If it is mentioned as analytical length, then K is equals to 100. D is equals to Ks cos square theta. S is stop intercept, that is normal stop intercept. Okay, this is the equation for the horizontal distance. Then we are moving to how to find out the RL. It is simple, we can find out from the figure. Okay, I know the RL of BM plus I am adding the backside. This is the equation, RL of BM plus backside plus V. This is the V. From the height of instrument line to the center of stop readings, that is S1, S2, S3. Okay, that is V plus V. For reaching the point P, I am subtracting the H1 value, that is H2 value. If the angle is in elevation, I am subtracting the H. If the angle is in depression, then we are adding the H1. Okay, so that we get the RL of P. This is the equation, that is RL of BM plus backside plus V plus or minus H1. we use minus when the angle is in elevation, we use plus when the angle is in depression. Okay, here we are also don't know the what is the value of V. For getting the value of V, we are taking same again, we are taking the similar triangle, that is ABC. Here sin theta gives a V by L. So V is equals to L sin theta. V is equals to L sin theta. From this equation we get the value of V. Okay, you have to remember both equation. That is, first one, the main equation is the horizontal distance equation, then the RL equation. The RL equation you can easily find out the RS by using the figure. You have to remember the horizontal distance formula. Let's do a problem on the when the staff is vertical. Okay, here the problem is one angle is in elevation and another angle is in depression. Okay, the elevation angle is 8 degrees 36 minutes and the depression angle is 2 degrees 18 minutes, and this negative sign indicates that the angle is in depression. Okay, and the staff readings are given S1, S2, S3, S1, S2, S3. Okay, we have to find out the distance D from here. Okay, the distance D and the RL of point B. In that, this distance or otherwise distance. It's your choice. You can find out only in the question he has given as find out a distance from the depression side. Okay, otherwise he'll also ask the find out the depression in the elevation side, whatever the formula is same. Okay, so for that we have to found out the H1 is already in our hand, 1.5 is H1 and H2 is 1.8. Then we have to find out V1, V2 and the distance D. Okay, then we can get the RL of B. So that first I had made a table as angle of elevation, angle of depression. In that I have written that theta and staff intercepts D. Okay, V. Then theta S V1. Okay, L. As I have said that directly we are not using that 1.5 meter. Okay, if we are using directly 1.5 meter, then I have to wrote that L formula as L is equals to K into S plus C. But I am not using this formula. I am using L is equals to Ks cos theta plus C. That indicates that we are using normal staff intercepts. Okay, let's do. S is 1.5 meter. Then the formula for D I have what we have derived in the video, that D is equals to Ks cos square theta plus C cos theta. But here we are using analytical lens where C is 0. So we can directly eliminate C cos theta. So Ks cos square theta, that is 146.64 meter. Then the V2 is L sin theta. Okay, L sin theta. Here L, what is L? L is equals to Ks cos theta plus C. Here the theta is 8 degrees 36 minutes. Okay, that we got the V2 kept aside. Then move on to the angle of depression, theta S V1 and L. As like we have done in the angle of elevation, we have same calculation we have done in the angle of depression. For calculating the RL of point B, okay, what is the formula? Okay, I am writing in this side. RL of B is equals to, first we have to come from this point, RL of BM. RL of BM plus H1, this part, plus V1 plus V1. We have reached to the line of sight. Okay, then height of instrument, we have reached to the height of instrument. Then plus V2 minus H2. this is the formula of finding out the RL of B. Okay, and the RL of B is 126.25 meter. This is the RL of B. What we have done, simply by drawing the figure you can easily get the RLs. Okay, just do one thing. RL of BM is given in the question, then plus H1, we have reached to this point, plus V1, we have reached to the height of instrument, then plus V2, when we have reached to the S2 level, but we don't need S2 level, we need the RL of B, then minus the S2, then we get the level of B, so that we can easily find out the RLs of this, of the point B. So you can also download these notes, class notes in our description. We are providing the link to download the files, okay, PDF files.